Yes, I was just going to do that. I was just looking and see if I started a new video on the other device. Okay. So e to negative x over 2. So remember, we are talking about when x approaches infinity. E to negative x over 2 is the same with 1 over e to x over 2. Is that okay?
Yeah.
Now, forget about this piece for a moment. When x approaches infinity, e to x over 2 also approaches infinity. Because e to infinity approaches infinity. So this denominator will always approach infinity. But now, when we have 1 over infinity, this will approach 0. Because imagine I divide a pie by everybody on the planet. Nobody will get anything. Not even a taste of it or a smell of it, right? So 1 divided by infinity approaches 0. So when we rearrange and we have the square root of x times e to negative x over 2, this can be rewritten as this. And this time we have infinity from the top and infinity from the denominator, which allows us to use L'Hopital's rule. So this piece approaches infinity, but this one, e to negative x, approaches 0. That's why we have this 0 times infinity, which is the lesser of the evils, right? So it's not that bad. Because just a little manipulation, I will not move this because this has power positive, but this has power negative. So you can move it to the denominator. And now you have infinity over infinity, and from here you can use L'Hopital's rule. Was that better?
Yeah.
Did I answer what the question was?
Yeah, I think so.
Okay, good. Thank you. Next question. Anything else? Thank you for doing this. I highly appreciate every time my students go back and look at the notes. It's invaluable, in my opinion, anyway. Okay, other questions, or we go back to 39 in 4.3. Does anyone else need help with WebAssign? Any question from WebAssign?
Can we look at any additional problems from 4.7?
Yes. Do you have any, or?
I could pick one for fun, I guess.
Is there something from WebAssign that you're working on, so we can move on with that?
Yeah, so I guess if you want to look at number 12 from 4.7, the problem asks about a piece of wire which is 28 meters long and is cut into 2 pieces. One piece is bent into a square and the other is bent into a circle.
And we want
wire?
Yes.
Sorry?
Yes, that was a question. How much?
The first part of the question asks how much wire in meters should be used for the square in order to maximize the total area.
Excellent. Perfect problem. Good. So we have 28 meters, and for some reason we want to build with this 28 a square, and we want to build a circle. And the square will have side x, so the area will be x squared, base times height. And here I have to have a radius. I'm going to call it r, so the area will be pi r squared. This is the function that we have to find the maximum for. But we can continue with this because I have one variable which is x and the second variable which is r. One of these two has to go away. It doesn't matter which one. Okay, so I'm coming back to my drawing board. And I know that the length of this piece, or this piece, was bent into a into a square, which means the length must be x plus x plus x plus x. So this must be 4x. This other piece was bent into a circle, but I have to think in terms of the circumference of the circle. Well, this piece has to be 2 pi r. The whole piece has to equal 28. So the 4x plus 2 pi r has to equal 28. That's what they told us. They are telling us that we have 28. We bend this piece into this, and we bend this piece into the circle. So the length of 4x plus the length of the circle, but we don't say that for a circle. We call it the circumference. We have the 2 pi r, so this is it. Of course, this is given to us so that we can get rid of one of these two, so we can do our thing. Critical number, first derivative, blah, blah, blah. I mean, I should say first derivative and then critical number. So that's what this is for. Now we only have to make a decision. Do we want to get rid of x or we want to get rid of r? Whatever is easier. It doesn't matter. They're both linear. So you tell me what you want to get rid of. Because from here, we must solve for x or y. I'm sorry, I meant r. So which one do you want to solve for? Because x, fine. So if you want to solve for x, then we move 2 pi r to the other side, 28 minus 2 pi r, and we divide by 4. That's our x. I would like to simplify it a little bit, pulling out a 2. Do not simplify like this. Do not simplify like this. I don't want to see that, please, I'm begging you. So pull out a 2, and we have 14 minus pi r divided by 4, and now you can simplify by 2. So then our x cleaned up. If you want, you can even separate it if it's easier, but it doesn't matter. So 14 minus pi r over 2. But remember, I have to square it. So I have to square this. So let's square this and put it in the area. And I am on page 4. Okay. Am I still centered? I have to make sure. Okay, so then x squared equals 14 minus pi r squared over 2 squared. Because when we square, we have to square the top, and we square the bottom. So square the top, we get this. Square the bottom, we get this. Now I'll put it in the area. And now I will say the area is indeed only function of one variable. With the x squared, which is 14 minus pi r squared over 4 plus pi r squared. I got my function. If you don't like r, just put x in there. It's fine. I mean, not like because we have x, so put y or whatever. It doesn't matter. Any variable. So, of course, I have to find a prime. So I differentiate, leave the 1/4 outside and differentiate that. 2 times 14 minus pi r to 2 minus 1 times the inner function prime, which is negative pi. One more time. 1/4 is outside. Bring down 2. Subtract 1 from the power times the inner function prime, which is negative pi. Plus 2 pi r. Okay, I want to clean it up a little bit. So I have a prime of r. I have 1/2. I will distribute in here. Do I want to distribute? I will not distribute, but I will distribute a negative sign. So I have a pi r minus 14 plus 2 pi r. So let's see what I did. So I simplified 2 and 4, and I have 2 in the denominator. I put the pi in front, but I really wanted to distribute a negative sign, so I can switch that in the correct order, and plus 2 pi r. Okay. So I still have to set it equal to 0. A prime of r, is not undefined. It's a linear function in R. Okay, then, almost there, almost. So I'm thinking I'm just going to write it first. I just want to simplify it as much as possible. And I see that I can get rid of this pi. I will divide by pi first. So I have 1/2 pi r minus 14 plus 2r. And I'm avoiding, but I have no choice now. So I really have to, I'll multiply both sides by 2. So pi r minus 14 plus 4r equals 0. So then I will have pi plus 4, r equals 14. I cannot combine these two. I have to factor out r, pi plus 4, and then 14 on the other side. So r equals 14 over pi plus 4. What is this? No clue.